Hello everyone. I mean,
Ma'am.
yeah, so this is your week 10 session. Have you all seen the lecture videos? No one has seen the lecture videos. Okay, have you seen lecture videos of week 9? Have you studied week 9? What is there in week 9?
Yes, ma'am.
Okay.
Kind.
Yeah, so if you have studied the concept of week 9, then week 10 will be easy for you. Okay. So study week 9 properly. Okay, that is going to help here. Okay. So in week 9, you would have studied about you would have studied about the random variable. Okay. So what is a random variable? Anyone? Okay. What are the kinds of random variable you have studied in week 9?
Discrete and continuous.
Discrete
Yeah.
and continuous.
Yes. So there are two types of random variable. Okay. So discrete and continuous. So in week 10 and 11, we will majorly study discrete random variables. Okay. Now I'm sharing my screen. Is my screen visible now?
Yes, it is.
Yes, ma'am.
Okay. Yeah. Just give me a minute. Yeah. So what is a discrete random variable? Anyone?
Random variable which takes countable discrete numbers from the number line.
Yeah, correct. So discrete random variable is something which you can count. Okay. Suppose number of students in the class. Okay. Number of balls in a bag. Okay. So the variables which you can count. Okay. That comes in discrete random variable. Okay. And whatever we measure, suppose we can measure height, we can measure weight. Okay. So these type of things comes under continuous random variable. Okay. So in this week, we will study how we can calculate expected value, how we can calculate variance, okay, and how we can calculate expectation and variance of function of a discrete random variable. Okay. Also, we will see some of the distribution based on discrete random variable. Okay. So some distribution you will study in this week, and the remaining you will study in week 11 content. Okay. So the very first topic is expectation. Okay. So suppose you have a random variable x. I will write the definition here. So let x be a discrete random variable. Okay, which can take values. Suppose it is taking value x1, x2, and so on. Okay. So the expected value of x, it is denoted by expected e of x like this. Okay. And it is defined as, so what is the formula for expectation? How do we calculate it?
Is a random variable for instance into the probability of that instance of random variable. Like
Yeah,
xi
correct.
into pi.
Yes, so it will be the values taken by random variable. Okay, suppose it is small x, and then you have to multiply it with the probability at that point, and you have to take summation over all. So basically, you have to take all the values taken by x multiplied with the corresponding probabilities. Okay, so this is the formula for expectation. Now, what is the meaning of this expectation? So, suppose we are doing an experiment where we are throwing a fair die. Okay, so we can get the numbers like 1, 2, 3, 4, 5, and 6. Okay, so suppose x is a random variable which is representing the outcome of this experiment. Okay, so what values x will take here in this experiment?
1 to 6.
Yeah, it will be 1 to 6 because it is representing the outcome of this experiment, and our outcome is the values. Okay, so it will be 1 to 6. Okay, now you can calculate the expected value. Suppose some value will come. Okay, suppose you are uh, calculating the expected value of this x. Suppose it comes out to be 3.5. Now, how will you interpret this thing? So, what is the meaning of this line? This value is, suppose you are, so basically, expectation is a long run average. Okay, so what is the meaning of long run average? Suppose you are throwing this die 100 times. Okay, you have to throw it for a large number of times. So, suppose for 100 times you are throwing a die. So if you are throwing a die 100 times, okay, suppose this is first throw, second throw, like this, there will be 100 throws. Okay, so on the first throw, suppose you are getting the value, suppose 3. Then suppose you got the value 4. Okay, then you got value 5. Suppose again you got 3. Like this, you will have some 100 values. You will have 100 outcomes. Yes or no?
Yes, ma'am.
Okay, so in this
Yes,
way, you
ma'am.
will have 100 outcomes. Okay, then if you take average of these values, average of the outcomes. Okay, so that is supposed to be 3.5. So this 3.5 is not that you will get the outcome as 3.5. 3.5. It is saying that the average of the outcome will be 3.5. Okay, so this is the correct interpretation of the expectation. Is this thing clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so it is a log and average. Okay, so here it is the average of the outcomes. Okay, for the large number of throws. Okay, so next we have Bernoulli random variable. Anyone knows about it? What is a Bernoulli random variable?
It takes only two values of.
It has two outcomes.
Yeah, so it is a random variable which takes only two values, 0 and 1. Okay, so wherever you have a situation where you can get only two kind of outcomes. Okay, suppose in an exam, you can pass or fail. Okay, you have two things, pass or fail. Okay, suppose you have a bag of balls where you have so many balls of, suppose, two colors. Okay, blue color and yellow color. Okay, you have so many balls of these two colors. Okay, so you are taking an variable x which will be representing that whether the color of the ball is blue or not. Okay, so either the ball will be of blue color or it will not be of blue color. Okay, so this kind of situation where you have two kind of outcomes. Okay, so that are modeled by Bernoulli random variable. So one is considered as success, okay, and zero is considered for failure. Okay, now I will write the definition. A random variable that takes on either the value 1 or 0. Okay, so this is called a Bernoulli random variable. Okay, so let X is a Bernoulli random variable. Okay, that takes values 1 with probability V, with probability P. Okay, so how can we write this thing? X is a random variable. First of all, we write the values taken by the random variable. Okay, and then we write the probability. So for 1, we are considering that the probability is P. So if for 1 the probability is P, what will be the probability for 0?
1 minus P.
It will be 1 minus P. Okay, so since it is a PMF, valid PMF, so the summation of these two probabilities should be equal to 1. Okay, so that's how this probability will be 1 minus P. Okay, now since we have seen this random variable X, okay, so now we will calculate the expected value of this random variable. Okay, so expectation of X, the formula is summation of X into probability at X. Okay, so here you can see that X is taking two values, 0 and 1. So the first value is 0. Okay, what is the probability? It is 1 minus P. Okay, then the next value is 1, and the probability at 1 is P. Okay, so now if you solve, it will come out to be P. Okay, so expected value of a Bernoulli random variable is P, and P is what? Probability of success. Okay, so success, you can define success can be different for different kind of experiment. Okay, suppose in that experiment where we had two color of balls. Okay, so maybe you are taking that if the color of the ball is blue, then you are considering it as success. Okay, maybe someone else is taking that if the ball is of yellow color, then it will be a success. Okay, so success can be defined in different ways. Okay, it depends on you, how do you want to define it. Okay, what is your objective of doing that experiment? Okay, suppose we have two situation, pass or fail. So maybe someone is considering, someone is interested in knowing about the fail percentage. Okay, so maybe in that case, the success you can take as failure. I mean, the success will be failing in the exam. Okay, are you getting my point? Yes, no, something. Okay,
Yes, ma'am.
okay, maybe passing in the exam is the like passing of like pass probability here. Okay, maybe you are interested in the failure, so in that case failure you will consider as success for Bernoulli random variable. Okay, so you solve different kind of question and you will see how you have to take this success thing. Okay, so this was Bernoulli random variable. Next we have discrete uniform random variable. So discrete uniform random variable is, so suppose X is a random variable, okay, that is equally likely to take which is equally likely to take any of the values, any of the values 1, 2, up to n. Okay, so we have n different values. Okay, X is a random variable which is taking values 1, 2, 3, and up to n. Okay, so the thing here is that this random variable will take these different values with same probability. Okay, so all the values of probabilities here will be same. Okay, so all of these values have equal chances. Okay, that's why it is written here that X is a random variable that is equally likely to take any of the values. Okay, now tell me what will be the value of probability here. Okay, you can use the
1 by
property
n.
PMF.
N, 1
Yeah, so it will be 1 by n. Okay, so the probability is 1 by n for all the instances. Okay, so in that case, we can check that if you take the summation of all these values 1 by n, 1 by n, so it is 1 by n, n times. Okay, so the summation will be equal to 1. Anyone has any doubt up to this point?
No, ma'am.
Okay. Okay. Again, we will calculate the expected value for this random variable. Okay. Since we have to study the expected value and variance. Okay. So first of all, we are studying the expected value. So according to the formula, we have to write the values multiplied with the corresponding probabilities. Okay. So we have to take all the values like this. So it will be 1 into 1 by n, 2 into 1 by n, then 3 into 1 by n. So similarly, it will be n into 1 by n. Now here 1 by n we can take as common. Okay, so in the bracket it will be 1 plus 2 plus 3 and up to n. Okay. Now what is the summation of n natural numbers? What
n
will be the
into
summation
n
of
minus
these?
N into N plus 1 by 2.
N into n plus 1 divided by 2.
n plus
Okay.
1.
So if you solve this will, yeah. If you solve, it will be equal to n plus 1 divided by 2.
Yes, ma'am.
Okay. Yeah. So this is the expected value. Okay, so next we will see that how can we find the expected value of function of a random variable. Okay, so till now we were studying the expected value of the random variable x directly. Okay, next topic is expectation of function of random variable. Okay, so suppose we have x as a discrete random variable, first of all. Okay, so x is a discrete random variable. So based on this variable x, we can define functions. Suppose gx is some function of x. Okay, so you can see that gx is the function of x. So suppose for an example, I can take that gx is what? X square plus 1. Okay, or maybe gx is x plus 5. Okay, or maybe gx is 3x plus 2. Okay, so you can see that these all are what? They are the function of x. Is it clear to everyone that what is the function of x?
Yes, ma'am.
Okay,
Yes, ma'am.
Yes, ma'am.
in this way, there can be multiple, so many functions can be defined. Okay, based on a variable x. Okay, now we have to see how can we find the expected value of this gx. Okay, so what is the formula for expectation of gx? Yeah, anyone? What is the formula for this?
X will be replaced with Gx now into Px.
Yeah, correct. Okay, so we have to write the value of the function at that point. Okay, so it will be gx multiplied with the corresponding probability at that value of x, and we have to take it for all the values of x. Okay, so that's why summation will come here. Okay, so for example, I can write, suppose x is a random variable which is taking some value, suppose 1, 2, and 3. Okay, so there will be some probability at that point. Okay, I am just writing, suppose they are a, b, and c. Okay, now we are defining a function gx okay, which is equals to x square plus 1. Okay, now we have to find expected value of gx. Okay, so what will we do? What we have to do here, summation of, it will be x square plus 1 multiplied with corresponding probability. Okay, and then what we have to do, we will put the values here. Okay, so first value is 1, then we have to put 2, then we have to put 3. Okay, and we have to multiply it with the corresponding probability. Okay, so if you put 1 here, what will be this value? What will be the value of the function?
2.
3. 2
It
to
will be 2. Okay, 1 square plus 1, 2, and the probability is a. Okay, this will be a. Next, the value of x is 2, so it will be 2 square plus 1. Okay, which will be 5, and the probability at 2 is b, so this will be b here. Next point is 3, so 3 square plus 1, it will be 10. Okay, and the corresponding probability at x equals to 3 is c. Okay, so in this way you can find the expected value for a function of a random variable x. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, so now there are a few things to remember. So suppose if a and b are constants, okay, if a and b are constant, okay, and you have to find expected value of ax plus b. So what will be the value of it?
AEX plus B.
So it will be a times expectation of x
summation of A.
plus b. Okay, so if you go back to week 3, if you remember the week 3 content, we have seen that if you have some value, suppose you have x1, x2 up to xn, okay, and the average of these values is x bar. Okay, now if you multiply with a constant, okay, if you multiply with a constant, suppose ax1, ax2 up to axn, now what will be the average of these values?
AX bar.
AX bar.
Ax bar. Okay, so now you relate it with this point,
Yes.
how it is coming out to be this? Okay, similarly if you add any constant, suppose x1 plus b, okay, x2 plus b, and xn plus b, then what will be the average value?
X bar plus B.
X bar plus b. Okay, so the same concept is used here. Okay, so if you are taking the expected value of x, and when you are multiplying with a constant and you are adding a constant, okay, so this will be the outcome. Okay, this will be the expected value. Okay, so for example, if suppose if a is 3 and b is suppose 6, okay, so this will be 3 expectation of x plus 6. Okay, expectation of a constant is always that constant value. Okay, anyone has any doubt up to this point? Okay, the next is variance. So variance, suppose again let x be a discrete random variable. Okay, with expected value mu. Okay, so expectation of x is equals to mu. Okay, expectation of x is mu. Now we have to find variance of x. So the formula is, it is defined as x minus expectation of x. Expectation of x is what? Mu. Okay, we have to square it and then expected value. Okay, so this is the formula for variance. Okay, expectation of x minus mu whole square. Okay, now you can just open the square. So this will be expectation and this will be x square plus mu square. Okay, and the next will be 2 minus 2 mu x. Okay, now this will be what will be the expectation of x square? You have to take the expectation inside it. Okay, so tell me what will be the expected value of x square? Simply it will be expectation of x square.
Yes.
Okay, then if you take
Yes, ma'am.
expectation to this term mu square, then what will be the value of this thing?
Expectation of
Mu
mu square.
square.
So you can
Yes.
write like expectation of mu square, but mu square here is a constant. Okay, mu square will be some constant value. Okay,
Yes.
and if you take the expectation on a constant value, then it is same as that constant value. So it will ultimately be mu square. Okay, so this will be mu square. Now when you take expectation to the last term, what should be this?
2 mu expectation of
Expectation of x.
It will be 2 mu expectation of
2
x.
mu expectation of x.
Yeah, because this 2 is a constant, mu is also a constant value. Okay, and x is some random variable. Okay, so expectation will come on this random variable. Okay, so you can solve it. So this will be expectation of x square plus this is mu square minus 2 mu. Now here you can see that expectation of x is mu. Okay, so you can write it as mu here. So you can see that it is mu square minus 2 mu square. Okay, so if you solve, this will be expectation of x square minus mu square. Okay, so this is the formula which we generally use. Okay, so you remember this formula? This is what? Variance of x is expected value of x square, and mu square is what? Expectation of x whole square. Okay, so this is the formula for variance, okay, which is generally used. Okay, anyone has any doubt up to this point?
Yes. No, ma'am.
no, no.
Okay. Okay, now we will see if you add a constant and multiply with a constant, okay, then how variance is affected. As we have seen here for the expected value, same thing we will see for variance. Okay, so suppose again if A and B are constant, okay, so variance of AX plus B. Okay, now tell me what it should be. Just think about the weekly variance.
A square variance of x.
Yes, it will be A square times variance of X. Okay, so this constant term will get squared. Okay, and then variance of X. And the variance of B will be equal to 0. Okay, so as you can see, B is a constant. So variance of B will be 0. Okay, so as we know, the definition variance tells you how the value is being changing. Okay, how is it fluctuating? So you can see that B is a constant, so it is not changing at all. So there is no variation in the value of B. Okay, that's why the variance will be equal to 0. Okay, variance of B will be 0.
Ma'am, just
Okay,
a question. So, like,
Hmm.
instead of B, if that was like Y, then Then how it will be changed?
Okay, so you're saying that ax plus y.
Yes. And
Okay.
y is not a constant.
Yeah, y is a variable. Okay, I am coming to this point only. Okay.
Okay.
So here, yeah. So here the thing is, if you have x and y, okay, are independent random variable. Okay. So now suppose you have to find variance of x plus y. Okay. So that will be equal to variance of x plus variance of y. Okay. But the point here to remember is the both the variable x and y should be independent. Okay. So actually the formula is like if you have to find the variance of summation of two random variable. Okay. Then covariance term will also come. Okay. A covariance term also comes here. But the thing is, if they both are independent, then the covariance will be equal to 0. Okay. So that's why the summation of variance of x plus y will be equal to variance of x plus variance of y. Okay. So the case where x and y are not independent, okay, so that thing is not here in your syllabus. Okay. So this will not be asked. Otherwise, okay, if x and y are not independent, then you have to use a different formula for summation of variance of two random variable. Okay. But in your syllabus, only this case is there. Okay. When the variables are independent. Is it clear to you?
I'm
Yes.
finding difficulty that if the two variables are independent or not, like throwing a two dice. So one variable is sum of the outcome should be 7, and the second variable, if the sum of the outcome is 5, then
Okay.
are
Yeah.
they
See, these
independent?
things that independent or not. So these things you will study in stats 2. Okay, when you start learning in stats 2, then there are the questions that you have to check whether x and y are independent or not. Okay, so there is a one thing that if the joint probability is equal to the product of the marginal, okay, then both the variables are independent. Okay, so these things you will study in the stats 2 course. Okay, so here in the stats 1, it will be given to you that whether variables are independent or not. Okay, and you have to like checking the independence of two random variables that will come in stats 2. Okay.
Hello, ma'am.
Yes.
Ma'am, can you please tell me about this one a square variance 6?
Yeah. Okay. So okay, this thing again I will say that just try to remember the week 3 content. Okay, so
Okay.
you have seen that suppose you have x1, x2, xn and random variables. Okay, so in week 3 there were no random variable. Okay, yeah, suppose x1, x2 up to xn you have some values. Okay, you have some values, suppose x1, x2 up to xn. Now you have to find the variance of it. Okay, some variance will come. Suppose sigma square is a variance. Okay, now suppose I am multiplying with a constant. Okay, ax1, ax2, like this, axn. Okay, now if you remember the week 3 content, okay, so the formula will be if you find the variance of these values, okay, where you have multiplied with a constant a. Now the variance of these values will be a sigma square. Sorry, a square sigma square. Okay, so if you want to verify this thing, you can just take any question, okay, where some values will be given. You can find the variance of those values first, okay. Then you multiply a constant, okay, and you find the variance of those values, and you can just check how this, like whether this formula is correct or not.
Yeah, I understand.
Sorry.
Okay, ma'am. Okay, ma'am.
Yeah. Okay, similarly, if you add a constant, So the constant term has variance 0. Okay, it is a fixed value, so there is no variation in that value. That's why the variance of a constant is 0. Okay, so if you can, like, you can write here that it will be variance of b, but ultimately this is 0. Okay, so that's why I'm not writing this term, because it has value 0. Okay, this thing you can just take any of the question from week 3 and you can verify. Okay, so in your syllabus there is this thing is there when two variables are independent, and then you have to find the variance of summation of those two. Okay, if they are not independent, then the formula has one more term which has covariance. So that is not here in your syllabus.
If the variable are not dependent.
If the variable are not independent, which means dependent. Okay, so there will be some covariance between those two variables. Okay, so these things again you will see finding the covariance. Okay, you will see these things for in stats 2 course. Okay, so we have seen expectation, we have seen variance. Now one more thing is that you have to find standard deviation. So standard deviation, we all know that it is the square root of variance. Okay, so simply you have to find the variance first, and then you just take a square root of variance, that is equal to standard deviation. Okay, anyone else has any other doubt? Otherwise, we can start solving the questions. I have collected 2 questions based on these concepts. Yeah, so this is your first question. Okay, just try to read it and understand it. So you can see here the question is, first question, in a box of numbered balls are numbered 1, 2, 3, and 4, such that the probability of drawing a ball is proportional to the number on the ball. Okay, this is the main information. Then the question is, if a ball is drawn at random from the box, okay, then what is the expectation of number on the ball drawn? Okay, so first of all, what we can do, we can simply write it as, like, you have to consider some variable x. Okay, you have to like write it mathematically. Okay, so suppose x is a random variable which is representing the number on the ball. Okay, so x is a random variable which is representing number on the ball. Now tell me what values x can take here.
1,
1, 2, 3, 4.
Yes, 1,
1, 2,
2,
3, 4.
3, 4. Okay, just read the question again. Here you can see that in a box of numbered balls. Okay, so you have some balls. Okay, on each ball some number is written. Okay, so number is 1, 2, 3, 4. Suppose this is 1, this is suppose 3, this is suppose 4, like this. Okay, then okay, this is the one thing. Next is the probability of drawing a ball is proportional to the number on the ball. Okay, so these are the values taken by variable x. Next is to find the probabilities for these values. Okay, so for this we are given that these probabilities, suppose probability p, it is proportional to the number written on the ball. Okay, so suppose the number written is 1, then the probability for 1 is proportional to 1. Okay, similarly the here suppose this is p1. Now the p2, okay, which means the probability for 2, it is proportional to 2. Okay, similarly probability for 3, it is proportional to 3. Okay. The next is this. Is this line clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now we all know that if you have to remove this proportionality sign, a constant term comes, right? We can write it as that P1 is equals to K times 1. Okay, whenever you convert the proportional sign into a equality sign, a constant term comes. Yes or no?
Yes.
Yes,
Do you all
ma'am.
agree with this?
Yes,
Okay.
ma'am.
Similarly, we can write that
Yes,
P2 is proportional to 2K. Okay. And then P3
Equals
is,
to 2K.
sorry, yeah, equals to 2K. So this will be P2 equals to 2K. Then P3 will be equal to 3 times K. And then P4 will be equal to 4 times K. Okay. Now I can write the PMF of X. So X, it is 1, 2, 3, 4. Probabilities are, this is K, 2K, 3K, and 4K. Okay. Now we all know the properties of PMF. So just tell me, how can we find the value of K?
Summation equal to 1.
we have to find E of X.
Summation of all probability will be 1.
Ma'am, E of X is equal to 1, so we can add the probabilities.
Ma'am, 1 into k plus 2 into 2k plus 3 into 3k plus 4 into 4k equals to 1. Okay, ma'am, we have to use PMF now.
Yes, ma'am, we can do like that.
Hello.
Hello,
Yes, ma'am,
yes,
you are
ma'am.
audible.
Sorry, Hello.
Yes, you
Yeah,
are
ma'am.
audible.
Yeah. Okay. Yes. So we calculated the value of k. Okay. Next to find equation of the represent the number one. Okay. So expectation of x is something we have to calculate here. Okay. So for which we know all the values of x, and we have also calculated
Ma'am, your voice
the
is cracking.
okay. Okay. Hello. Screen is visible to you?
No, ma'am.
Yes, ma'am.
No, ma'am.
Okay. So just
Ma'am, your
on
voice is cracking again.
now is it visible?
Yeah, ma'am.
Yeah.
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay, yeah. So we were calculating expected value of x. Okay. So you can see that we know the values of x, and we have also got the value of k, okay, which will help us to get the probability values. Okay. So this will be 1 by 10, 1 into 1 by 10, which is 0.1. Okay. Plus it will be 2 into 2 by 10. Okay. So this will be 0.2. Then it will be 3 into 3 by 10, which will be
Now we
0.
can take out 1 by 10 common, right?
Yes, yes, you can do that way also. Okay, then it will be 4 into 0.4. Okay. So you just solve and tell me what will be the expected value of x.
3.
So, yeah, it will be equal to 3. Okay. So expectation of x is equals to 3. So is this question clear to everyone? You can just read the question again. I will show the question. If anyone has any doubt, then you can ask. Is it clear to everyone?
Ma'am,
Yes, ma'am.
Yes,
Yes, ma'am.
yes, somebody
ma'am,
is
Can
asking.
you just explain this question once more? Because there was so
Okay,
much of
okay.
network issues.
Okay, I'll explain. So you can see that the question is in a box of numbered balls, ball are numbered as 1, 2, 3, 4, such that the probability of drawing the ball is proportional to the number. So first of all, there are some balls. Okay, on each ball, some numbers are written. Okay, suppose this is ball 1, this is suppose 3, this is suppose 4, this is suppose 2. Okay, so so we have taken a variable x, okay, which is representing these numbers. Okay, number on the ball. Now in the question it is given that the probability of drawing a ball is proportional to the number on the ball. Okay, so that's how we have written this line. So probability of this, suppose this is P1, this is P2, this is P3, this is P4. Okay, so P1 is proportional to 1, P2 is proportional to 2, and P3 is proportional to 3. Similarly, P4 is proportional to 4. Okay, now when you remove this proportionality sign and convert it into equality sign, constant term comes here. Okay, so P1 will be equal to K times 1. Okay, P2 will be 2 times K times 2 or 2 times K.
Yes,
Then
ma'am.
P3 will be 3K and
Got
P4 will be 4K. Okay, now we have written this value here. Okay, and then by using the property of PMF, okay, this summation should be equal to 1. So from here we calculated the value of K. Okay, now we have all the things to calculate the expected value of X. Okay, we know the values of X and we know the probability values also. Okay, so by using the formula
Yes,
we
ma'am.
can
Got it, ma'am.
find the expected value.
Thank you, ma'am.
Okay, yeah, then solve the next question. So here this information is same. Okay, this is actually a subpart of this question. So again, this is the same information in a box of numbered balls. Our balls are numbered 1, 2, 3, 4, such that the probability of drawing a ball is proportional to the number. So if a group of 3 balls is drawn at random with replacement from the box, what is the expectation of sum of the numbers on the ball? Okay, so first of all, we need to like convert this theory into some mathematical notations. Okay, we should know what is X, we should know what we have to calculate here mathematically. Okay, so first of all, we should decide on those things. So, okay, I will write. So again, suppose Xi is the number on the ith ball, suppose ith ball drawn. Okay, so now what is the expected value of Xi? Can you tell me? It will be 3. It is the same thing. You can see X is the number on the ball. Here I have just written it for the ith ball. Okay, both are same thing. So expectation of Xi will be equal to 3. Do you all agree with this?
Yes.
Okay, I you can take as like here we are taking 3 balls. So I will be 1, 2, and 3. So we can say that expectation of X1 is equals to expectation of X2 is equals to expectation of X3, and it is equals to 3. Is this line clear to everyone?
Yes, ma'am.
Once more, I will say that, I will explain what is the expectation of X1. So X1 is representing the number on the first ball drawn. Okay, so suppose out of the so many balls, you are selecting first ball. Okay, so expectation of X1 is the expected number which will be written here. Okay, written on the ball. Okay, so this is 3. The expectation is 3. Okay, so this expectation will be same for all the 3 balls. Okay, that we have calculated in the first part of this question. Okay, now just read this part, that if a group of 3 balls is drawn at random with replacement from the box, then what is the expectation of the sum of numbers on the ball drawn? Now, can you tell me what is to be calculated here mathematically?
Sum of all
So basically, we have to find expectation of x1 plus x2 plus x3. Okay. Just read this line again. What is the expectation? Okay, this is expectation. Then sum of the numbers on the ball. So x1 plus x2 plus x3 will be sum of the number on the ball. Now this line makes sense to you? This is something we have to find. Is it clear to everyone or not?
Yes, ma'am.
Yes,
Okay.
ma'am.
Basically, the expectation of the three ones, right?
Yeah, expectation of summation of these three. Okay, we are
Oh, okay, ma'am.
taking three balls. So that's why it will be x1 plus x2 plus x3. Okay, you can see that sum of the numbers on the ball drawn, and we are drawing three balls. Okay,
Yeah,
so
ma'am. Yeah.
yeah, so this is something we have to calculate. So if you,
How will we solve if the question states like without replacement?
yeah, so then also it will be same, because you can see the question here is that what is the expectation of sum of numbers on the balls drawn. Again, you have to find expectation of x1 plus x2 plus x3. Okay, it does not matter that the balls drawn are with replacement or without replacement here. Okay, because here we are like interested in the number on the ball. Okay, no matter how, in which way we are taking the balls. Okay, so if you want to write this question properly, I will consider that y is some random variable. Okay, let y be the random variable representing.
Ma'am, we are drawing the three balls at a single time. We are not like uh, drawing one, then another, then another. So is it like not ambiguous that we are adding the three? Like it should be multiplied, like it is the intersection, right?
Sum is given a
Given.
sum of the numbers of all terms.
Okay, 1 minute, I'll explain. Okay, so you can see that you just read the last line. What is the expectation of sum of numbers on the ball drawn? Okay, so the thing is you have drawn three balls. Okay, does not matter how you have drawn it. You have drawn three balls. Okay, just forget this thing that how we are uh, drawing these three balls with the replacement or without replacement. Okay, we have drawn three balls. Now we have to find expectation of sum of numbers on the ball. Suppose some number is written, suppose 2. Here, suppose 3 is written. Here, suppose 1 is written. So we are interested in the expectation of these three values. Okay. So here, like whether you're choosing the ball with replacement or whether you are choosing it without replacement, that is like that will not affect this expected value.
Okay, ma'am.
Okay, we
Got the
are
idea.
interested in the summation. Okay, like summation, expected value of summation of the numbers written on the ball.
Yeah, ma'am. I understood the idea. Okay. Thank you.
Yeah. Okay. Okay, so basically we have to find expectation of some of these three. Sorry,
We
your
are
voice
having
is not clearly.
expectation as 3, right?
Your voice is not clearly audible to me. Can someone tell what he's saying?
Ma'am, the expectation, it is here as 3, right? So does this mean that in the long run, if we'll pick a ball, the maximum number of 3 balls will be there, number having a 3. ball will be there. Does that mean
See, this summation expectation of y, which is expectation of x1 plus x2 plus x3. Okay, so it is saying that if you are suppose repeating this trial, okay, if you are suppose taking the ball 3 times, sorry, you are taking 3 balls, okay, you are doing this thing suppose 100 times, okay, so it is saying that that the summation, okay, if you take the summation, okay, so this average value, okay, suppose in the first draw, like first time, you have drawn 3 balls, okay, you got 3 balls, suppose 1, 2, and 3, and then you have to take summation. Some value will come, okay, this summation. Then you are doing this thing third time. Again, you have drawing 3 balls. Suppose the numbers is 3, 2, 4. Then you have to take summation. Okay, some value will come. So this thing you are doing 100 times. Some value. So this is what summation value. If you take the average of these values, so that will be the expected value which we are calculating here. Are you getting the idea?
okay? Got it.
Yeah. So expectation is the, like, now you can understand it is the average of the long run. Okay. So yeah, this is something we have to find. So I have just written that y is the random variable which is representing the sum of the numbers on the ball. So this will be equal to,
9.
yeah, so this will be expectation of x1 plus expectation of x2 plus expectation of x, okay, and all have value 3, 3 plus 3 plus 3, so which will be equal to 9. Okay, so this is like correct way, like proper way of writing a question. So your exam is objective, but if you have to do, like if you have to give any subjective exam, then you should write it like this. Okay. Anyone else having any other kind of question here? Any doubt? Okay, then so
Ma'am,
so here let x. Yes.
ma'am, actually,
Yes.
I have an important question, but not related to this. I am facing a problem with the support, understanding it with the support email. So just give me a minute, please. I want to ask it. Um Ma'am, I passed my qualifier reattempt exam, and I'm confused about like submitting the weekly assignments after week 5 onwards, because I'm still receiving. So I was scared, but that maybe I have to submit them. So I did submit them like up till now, uh, uh, till like week 9. So and there are more assignments that are coming. Like more content is coming. Do I have to do like week 5 onwards assignment and stuff? Like, and the assignments that I'm receiving, will they be considered? Eh, and do I have to do like continue in the same term or the next term in the Jan term? I'm
Okay.
confused.
Have you mailed to supporting?
Yeah. Uh,
So
they said that
yeah.
I
So
have to do like in the Jan term. So week 5 on, just I wanted to confirm that week 5 onward assignments I don't have to do, right? Because then they won't be considered in my
see,
next term.
whatever support team has answered you, you have to do that because these things I also am not sure. Okay, so they decide like what is the eligibility and all. So whatever they have said, that will be correct. Okay, so you have to follow that.
But so I have to ask them about like, do I have to submit weekly assignment? Because I asked when I was like, I had registered for the reattempt qualifier exam, but they just gave me, yeah, that that you register like the same email that if you have failed the qualifier, then you submit the fees, and then if you're absent, you submit the fees and everything,
Okay, whatever.
like the same email. But there was no like information about like week 5 onwards, do I have to submit the assignments or not?
Okay, you can mail them again. Okay, they will answer you. Okay, because they are the correct person to answer this question. Okay.
um so I have to ask them about like, do I have to complete like week 5 onwards assignment or not?
Yes, yes, you can. Yeah, you can ask these kind of questions there to them.
But at least like I have to continue in the Jan term, that is like confirmed for the qualifier reattempt people, like at least that much.
Okay, I'm not sure right now. Okay, you can do one thing. You can just post your query on Discourse. We will check and reply you there. Okay.
Okay. Okay. Thank you, ma'am.
Yeah. Okay. Okay. So this is your next question. Let X be the random variable with the following PMF. A function of a random variable gx is defined x square plus 3. Okay. So we have to find what is the expected value of gx. Okay. I hope you all can solve this question.
Yes,
I
ma'am.
got 5.2.
Yes, ma'am. Even I got 5.2.
Okay, good. So I will solve it. So expectation of gx, so which means expected value of x square plus 3. Okay. So now you can solve it in two different ways. Okay. First of all, you can write it like this is expectation of x square plus expectation of 3, which will be 3. Okay. Other way can be that you can just use the formula that we have discussed earlier. Expectation of x square plus 3. You can find it in this way. Summation of x square plus 3 multiplied with the corresponding probability. Okay. So there can be two ways to solve this question. I am solving it by using this method. Suppose, so for this, you have to find the value of expectation of x square. Okay.
Ma'am, I
So
got the answer
here,
5.
okay, I will solve it and then you can match. So this is x square
Okay, ma'am.
probability of x. Okay. So x taking values -1. So -1 square into 0.1 plus 0 square into 0.15 plus 1 square into 0.3 plus 2 square into 0.45. Okay. So expectation of x square will be equal to 2.2. Okay. And then expectation of gx, that will be expectation of x square plus 3. So this is 2.2 plus 3, which is equals to 5.2. Okay. Okay. Is this question clear to everyone? Okay. Or simply you can just put the value in the in this formula directly, x square plus 3, and then multiply with the corresponding probability, and directly you will get the answer. Okay. Or you can solve it in this way. Both are correct. Okay. Both will give you the same answer. Okay. Anyone having any doubt in this question? Just say yes, no.
No,
No,
ma'am.
ma'am.
Okay, then solve this question. So in a box, there are 10 chocolates, of which 6 are milk chocolates and 4 are dark chocolates. 2 chocolates are drawn random without replacement from the box. Okay. So find the probability that one dark chocolate is drawn among those two randomly drawn chocolates. Okay, this is the simple probability equation. Okay, then in the second part, we have to find some expectation. Okay, so solve the first part. So here I am taking that, suppose x is a random variable. Okay, let x be a random variable which is representing number of dark chocolates drawn from the box. Okay, so what we have to find? We have to find probability that x is equals to 1. Okay, so what will be the value? So in total, we have 10 chocolates. Okay, in total, we have 10 chocolates, out of which we are drawing 2 chocolates. Okay, now here you can see that one dark chocolate is drawn among those two randomly drawn chocolates. Okay, so dark chocolates are 4 in total. Out of the 4 dark chocolates, we are selecting 1. And then the remaining 1 chocolate, okay, we will be selecting from the remaining 6 chocolates. Okay, so it will be 61. All this value, what will be the answer?
Forty-eight upon 90.
Six by five.
0.53. This is answer. Okay, is this question clear to everyone? Okay, then solve this question. So it is also the subpart of the same thing. This information is same. Now here we have to find what is the expected number of dark chocolates drawn. Okay, so expected number of dark chocolates drawn, which means we have to find expectation of x. Yes or no? Okay, again, x is the same. I will write it here as well, that x is a random variable. Let x be a random variable which is representing number of dark chocolates drawn from the box. Okay, so we have to find expected value of x. Okay, so how will you calculate it? What things we need here to calculate the expected value of x? Am I audible?
We'll mark X as 0, 1, 2.
PMF.
Yeah, so we should know the PMF of x first. Okay, so for which we need to know two things. So x, the range of x, what value is taken by x. So x is representing number of dark chocolates drawn. So we are drawing 2 chocolates. You can see in the previous question, we are drawing 2 chocolates. So what values will be taken by x here?
0, 1, 2.
0, 1, and 2. Okay. So maybe we are selecting 0 dark chocolate, or maybe 1 dark chocolate, or maybe 2 dark chocolates. Okay. Now we need to calculate the values for all these points, 0, 1, and 2. So probability x is equals to 1, x equals to 0. Then we have to calculate x is equals to 1, and then probability x is equals to 2. Okay. So probability at x equals to 1 we have calculated, it is 0.53. Now calculate the rest too. Are you all getting the same values?
Yes, ma'am.
Okay. Now we can calculate the expectation of x. Okay. So at 0, probability is 0.33. Then at 1, it is 0.53. Okay. And then at 2, it is 0.13. Okay. So this will be equal to, this is 0 and this is 0.53. And then 0.26. This will be 0.79. Okay. So here in this question, we don't need to calculate the probability as x equals to 0 because ultimately this term will be 0. Okay. So you don't need to calculate it. Okay. Is this question clear to everyone?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. Now this question. So the question is, the past records of a football club in the golden goal matches are analyzed. Assume that the result of a match is independent of the other matches. Okay. Then xi is taking two values, 0 and 1, with these probabilities, where x equals to 0 if team loses and x is equals to 1 if team wins. Okay. So what is the expected number of wins in 5 matches? So just read this question again, think about it, and tell me what we have to calculate here.
Ma'am, expectation would be 0.6 for 1, right? And we can multiply 5 with that.
Yes, correct. Okay. So we have to find expected number of wins in 5 matches. Okay. In this xi, you can see it is a Bernoulli random variable taking two values. Okay. So it is representing that. So 1 is for winning. Okay. So the probability for winning is 0.6. Okay. And 0 is for losing. So the probability for losing is 0.4. So first
Ma'am,
of all,
how
we
do
will.
you understand which one is Bernoulli variable and which one is not?
Okay. See, Bernoulli, again, Bernoulli is a random variable which takes two values, 0 and 1. Okay. So here you can see two outcomes will be there. So here you can see 0 and 1. So 0 is like the team is winning the game. Okay. There can be two things. Either the team will win or it will lose the game. Right. So two
Yes, ma'am.
outcomes are possible. Okay. So here in this question, 1 is for winning and 0 is for losing. And their corresponding probabilities are also given. Okay. So these kind of variable are called Bernoulli random variable.
Oh, okay.
Okay. Where you have two kind of outcomes.
Okay. Thank you.
Okay. So here expectation of xi, this will be equal to what? 0 into 0.4 plus 1 into 0.6. Okay. So this is 0.6. Okay. Now, question is to find expected number of wins in the 5 matches. So suppose I am taking that S, okay, it is some random variable which is representing the number of matches, okay, won by the football club, won by the club in 5 matches. Okay. So S will be equal to what? Summation of xi, and I will be equal to what? 1, 2, 3, 4, and 5. Okay. Now you can see, again I'm writing, so S is equals to what? X1 plus X2 plus X3 plus X4 plus X5. Now just look at this line. So X1 is representing that in the first match, okay, whether they are losing the game or winning the game. Okay. Similarly, X2 is for the second match. Okay. So X2 is taking two values, 0 and 1. Okay. So 0, if it is taking value 0, then the second match is lost by the club. And if it is taking value 0, taking value 1, then the team is winning the game. Okay. So similarly, since it is given that we have to find the expected number of wins for 5 matches, so we have taken X1, X2 up to X5. Okay. So these 5 variables will tell you, like the values of these variables will tell you that they are winning the game or losing the game. So if you take the summation of these random variable, okay, that will give you like in out of the 5 matches, how many matches they are winning. Okay. So suppose for an instance, you can take, suppose in the first match, they are winning the game. So X1 will be taking value 1. Yes or no? Yes, no? Okay. Suppose in the second match, they are losing the game. So what value will come here for X2?
0 into 0.4.
0,
Sorry.
only 0. Okay.
0.
Then suppose in the third match, suppose again they are losing the game. So for X3 also, the value will be 0. Okay. Then suppose in the fourth match, they won the game. So the value for X4 will be 1. Okay. Similarly, suppose in X5 also, in the fifth match also, they win the game. So this value will be equal to 1. Okay. Now if you calculate the value of S, that will be equal to what? 3. Okay. So 3, the value of S equals to 3, which means that out of 5 matches, 3 matches are won by the club. Are you getting the interpretation of these things?
Yes.
Okay. So that's how we have made this variable S, which will be equal to the summation of these 5, x1 plus x2 plus up to x5. Okay. Now we have to find the expected number of wins in the 5 matches. So we have to find the expected value of S here. Okay. That this was for just to explain you. So we have to find expectation of X. So expectation of X will be expectation of summation of these 5 random variables. Okay. So the value of expectation of Xi is 0.6. So this will be 0.6 into 5. Okay. So this will be 3. Now is this question clear to everyone?
Yes.
Okay. So the question will be given to you in some theory kind of, and you have to interpret like what you have to calculate mathematically. Okay. If you're able to do that, then you can solve the question easily. Okay. Okay, then this is the next question. So the past record, okay, so this information is again the same. Here you have to find what is the variance of the number of wins in the 5 matches. So tell me what we have to calculate. Mathematically, what will you calculate?
Expectation of x square minus expectation of x whole square.
Yeah, that is correct. But ultimately, what we have to find? I mean, in the previous question, we had to calculate expectation of S. So here, what we have to calculate?
Variance of
Variance of S simply. Okay. You can see that here it was written expected number of wins in the 5 matches. Simply here it is written variance of number of wins in the 5 matches. Okay. So we have to find variance of S. Okay. For calculating variance of S, we need to calculate variance of X. Okay. So we will calculate variance of X first. So this is equals to expectation of X square minus expectation of X whole square. Okay. So we have 5 random variables. So I can write it as for xi. Okay. Now expectation of xi is square. First of all, what is the expectation of xi? This we calculated in the last question. It is 0.6. Okay. Then calculate expectation of xi square. So this will be 0 square into 0.4
Okay.
plus 1 square into 0.6. Yeah. So it will be same as 0.6. Okay. Now variance of xi. So expectation of xi square is 0.6 minus expectation of x whole square. Okay. So 0.6 minus 0.036. This will be 0.24. Okay. We have to calculate variance of S. Variance of S means variance of x1 plus x2 up to x5. Okay. Now in the question, you can see it is given that assume that the result of a match is independent of the other match. Okay. So indirectly, it is given that these variables x1, x2 up to x5 are independent. Okay. So since they are independent, we can write that it will be equal to variance of x1 plus variance of x2 plus variance of x3 up to x5. Do you all agree with this point?
Yes, ma'am.
Yes, ma'am.
Okay. So since all are having same value, okay, it is 0.24. So we can multiply it with 5. It will be 1.2. Okay, is this question clear to everyone?
Yes, ma'am. And how we will interpret that if the team has played 5 matches, then
Yeah,
uh,
that is given in the question. Okay. So in the question, they are interested in the
no,
number
if
of wins in the 5 matches. Sorry.
okay. So the what will be the like application? If the team plays 5 matches, then the variance will be like in the previous question.
Hmm.
If
Yes.
the if the team played 5 matches,
Hmm.
the expected win from that those 5 matches will be would be 3. From the
Yes.
variance, what we will know? Like
Variance is the variation in this number. Okay, so you're asking about variance of X or variance of S. So variance is like, suppose you have some, okay, uh, if you have some values, okay, you calculate the average. Suppose it is mu, okay. Then you have variance and standard deviation. So variance have squared units, okay. So we take standard deviation, okay. That is in the same unit as the variable X, suppose. So mu plus minus sigma is something we can say that values will be lined. Okay, so you can have in rough estimate that expected number of wins in the 5 matches is 3. Okay, and this value can vary with the value of the standard deviation. You can just add or subtract. Okay, you can take standard deviation from here. Okay, and then you can find like how much fluctuation will be there.
Okay.
Okay, because it
So
will
from
not
the
be like
standard deviation,
strictly,
we can know the.
yeah.
Okay, got it.
Okay, now is this question clear to everyone? Any other doubt? Okay. Yeah, so this question, let y equals to as plus b.
Ma'am,
Okay,
sorry.
this is how.
Question.
Hmm.
So variance and standard deviation basically calculate fluctuation only, correct? But standard deviation unit is same as the variable.
Yes.
So they both
Standard
measure
deviation.
something.
Mm-hmm. Yes, go ahead.
Sorry, I mean they both measure basically same thing only, fluctuation, correct?
Yeah, fluctuation also you can say. So variance and standard deviation both tells you about the variation in the values. Okay, the problem with variance is that the units gets squared. Okay, so that is not in easily interpretable. So we take a standard deviation because standard deviation have same units as the variable. Okay, suppose you are calculating some variance of the some data which has unit centimeter. Okay, so variance will have unit centimeter square. Okay, that is like difficult to interpret, but standard deviation have same unit that will be centimeter, so that you can easily interpret. Okay,
Okay.
but they
Okay.
both tell you about the variability.
Okay. So standard deviation is more suitable to compare the variability rather than variance.
Yes, because you can interpret it easily. Okay,
Okay, got it.
okay, both are related. Okay, standard deviation comes from variance only because like they are square root of standard deviation is square root of variance, or you can say
Okay.
that variance is square of standard deviation. Okay, so both are connected.
Okay, got it.
Okay, now solve this question. So here y is equal to ax. Okay, so a and b are constant here. It is not mentioned in the question, but yeah, it is constant. Okay, and y and s are some variable. So which of the following is are true?
First and
These
third.
three
One
options
and
are
three.
First and third.
First and third.
yeah, first and third will be correct. Okay, also it is like simple. We discussed it. So y is equals to as plus b. So we have already discussed this thing. A and b are constant. So simply it will be a times expectation of s plus b. Okay. Second is variance of y. So variance of y is variance of a s plus b. So this will be a square times variance of s. Okay. So b is a constant. Variance of b will be 0. Okay. So first and third are correct here. Okay. Yeah. So this was the last question. If you have any doubt in any of the question, you can ask me. Anyone has any doubt in any of the question?
Ma'am, can I ask from week 9?
Week 9. Okay, week 9, did you ask the question in the
Ma'am,
week 9 out session?
ma'am, from GA last question.
Okay, GA. Okay, for GA, we provide the solution PDF.
Oh, okay.
Okay, so you can check
Where
from
can I
there
check?
first.
But for week 9, it is not uploaded in the drive link.
Okay, it is not uploaded. Okay, we'll check and we will upload it. Okay,
Okay, ma'am.
and you can check the solution from there first. And still, if you're not able to understand, then you can ask.
Yeah, okay, ma'am.
Okay, anyone else having any doubt? So you all
No.
try solving the activity question. Okay, activity, practice assignment, all the other questions which you have, and then you can ask me in the doubt session. Okay, on Tuesday.
Ma'am,
If you
can I
have
get
any other
Thank you.
conceptual doubt, you can ask me now. Sorry.
can
Sorry, you're not audible to me properly.
ma'am, LinkedIn, if you can.
Okay, my LinkedIn ID. Okay, it is with the same name. You can search it.
Can you share this document?
Yes, I will upload this PDF on the portal. You can find it from there. Okay, it will be uploaded under supplementary content.
Okay, thanks.
Yeah. If no one has any other question, then we can end the session.
Okay, ma'am. Thank you.
Yeah, thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.